All right, so here we have the first problem on the practice problems that I gave via the Google Classroom. And you see we have this initial circuit here where we go from the power source to a parallel branch, R1 and R2 are parallel to one another. And they're in series with R3, which is in series with R4. And the first thing we have to do is rank the currents. So let's take a look at this circuit and see what's happening. So the current leaves the battery and gets to this junction here, and some of it will go through the top resistor and some will go through the bottom resistor. So I know both R1 and R2 don't have the full total amount of the current. The current then comes together on the other side of the resistors at junction A here, and off it goes, right? So this full current then goes through resistor 3 and through resistor 4. So both 3 and 4 are equal to one another in terms of the current going through them, and they are both greater than R1 and R2. But now we need to take a look at R1 and R2 and decide which one, if either, has more current going through it. Well, part of the problem, it tells you in the setup that R1 is less than R2, which is less than R3, which is less than R4 in terms of their resistance values. So R1 is the smallest resistor in this circuit, so it's smaller than R2. And if the current going into this junction here is a certain value, more of it will go down a smaller resistance and less of it will go down to the greater resistance. And so R1 must have more current going through it because it is the smaller resistor. And so finally, to put the rankings together, we have R1 is great. This is the current of R3 equals the current of R4, which is greater than the current of R1, which is greater than the current of R2. So taking a look at this just one more time, both R1 and R2 are in parallel, right? So they both have the same voltage. That's a rule for parallel. But R1 is smaller. R1 is smaller than R2. And so the same number divided by a smaller number will give you a bigger quotient. So we see the mathematics has I of R1 being greater than the current through R2. Next, we got to figure out the voltage in the across the second resistor and the voltage across the third resistor. But we are given some information. We are given that the voltage across R1 is V1, which equals 1 volt. Okay, and we know that R1 and R2 are in parallel, so the voltage across R2 will also be 1 volt. Next, we just got to figure out what's going on with R3. Okay, so there's 15 volts total to this circuit, and one of it goes to these devices. 9 of it goes to this device. And so we know that we have to add up all the voltages in series, right? So the 1 volt here that is in series with R3 needs to be added together. And that needs to be added to the voltage across R4, which is in series, to get the total of 15. And so the voltage total is going to equal the voltage across 1 and 2 plus the voltage across 3 plus the voltage across 4. And we have all the values now except for 3. And we'll just do a little bit of math. So 15 volts equals the 1 volt across both of those resistors plus V3 plus 9 volts given to us in the problem. And we have ourselves 5 volts equals V3. So there's 5 volts going across this resistor. All right, the last part of the problem says, now connect a wire from A to B, right? So we're going to put a wire there, and essentially, what does that do? It cuts out R3 because that wire essentially has no resistance in it, so the total current will go through that wire, skipping R3, and it'll just go from the parallel branches right to R4, right? So if I were to just like redraw it, that circuit, when we short circuit it, it would just look like, whoops, it would just look like this. Okay, so now let's figure out what would happen to I1, the current going through the first resistor, if this was our circuit. Okay, so without this third resistor here, as part of the circuit, and since it was in series, we have just reduced the effective resistance of the entire circuit. If we reduce the effective resistance of the entire circuit, well, then we know that the total current must be going up. Given the same voltage from before and a smaller resistance, the current must go up. So regardless of what that value is, so long as it's a greater value than it once was and these two resistors remain the same value, R1 will still then have an increase of current going through it due to the increase of the total current by cutting out the third resistor.